Hello everyone, welcome back to our lecture series on power electronics. We are at the end of this course and today I am going to discuss on solution of few previous year GATE questions from the topic inverter. So let's start. So here we have I have considered last 5 years GATE questions from the topic inverter, and correspondingly I'll solve and I'll show you how to solve or how to deal with the problem from inverters. So whatever the concepts I have given in last 6 to 7 lectures, possibly 7 to 8 lectures, so from there only you can, I think you will be able to solve these problems. So let's start with first problem. This is problem number 1. So how to solve the problem I have already told you in the last problem solving session, that first of all we have to read the question very carefully. Once the reading is complete, reading means you have to read and understand the complete question, what it is asked. Then you have to first note down, means you have to note down what are the given. Then you have to find out what we have to solve or what we have to find out. So with that procedure I will proceed here. So first question is that a single phase full bridge inverter excuse me, fed by 325 volt DC, obviously, produces a symmetric quasi square waveform across AB as shown. Where it is shown? This one. This is shown here. This is the quasi square waveform. To achieve the modulation index 0.8, the angle theta expressed in degrees should be what? You have to find out the angle theta. That means this one. You have to find out the angle theta. Let me, I think changing color will help. This angle theta we have to find out. That is the VAB, and this is the output voltage, which is quasi square wave. And to achieve modulation index 0.8, what should be the value of theta, that we have to find out. Now modulation index definition is given here. Modulation index is defined as the ratio of the peak of the fundamental component of AB. This is the peak of the fundamental component of AB to the applied DC value. So now if we solve the peak of the, if we can find out the peak of the fundamental component of the VAB, then possibly we will be able to solve it. Now for that we have to express this waveform. This is the waveform. You have to express it in terms of various frequencies, and from that we have to take the fundamental frequency, and from there we will be able to solve it. Now the VO omega t, if I express it, this first we have to find out Bn. So basically you can see this is the half wave symmetry and square wave, yes, quarter wave symmetry. If it is half wave symmetry and quarter wave symmetry, so before going to express this one, I am just showing you in the exam. If you can remember, that will be helpful for you. Otherwise you do it very quickly, this part you will not get that much of amount of time, but for explaining I am just solving this part. So what is that? From theta to pi by 2, if I do it, then it will be sufficient, because it is a quarter wave symmetry as far as I can see. So Bn will be, what will be the Bn? So Bn will be 4 by pi integration of theta to pi by 2 V output d omega t, VO d omega t. So what is VO? The VO d omega t. This is the expression. Now instead of VO, I will write it. What is the detail? Which is VDC. What is VDC? VDC here is 320 volt. VDC is 325 volt, not 320. Sorry. So what is that? This is VDC into, suppose say this is sine n omega t. sorry, I have missed out the sin omega t, n omega t, sorry for that, n omega t d omega t. So next, in next step, what we can find out, VDC will take it out from there. So 4 VDC, and if we do the integration, we will get n at the denominator. So n into pi, and this one will be minus of cos of n omega t. So this is theta to pi by 2. So theta to pi by 2, if I solve it, so what we will get it? We will get, this is 4 VDC by n pi. This one will be, if I take this minus, so cos theta will be that side, cos theta minus of cosine of, sorry, n theta, this will be n pi by 2. So this one. Now what is the value of n? N equals to 1, 3, 5, these are the odd numbers. So in that case, what will happen? We will get this part 0. We will get this part 0. So what will be the final expression? This will be 4 VDC by n pi cosine of n theta. Fine. So now what will be the output voltage expression? VO omega t. So VO omega t will be summation of n equals to 1, 3, 5 this way till till infinity. Now what we get? 4 VDC by n pi. Then there will be a cosine of n theta into sine of n omega t. This one. You can directly write this equation, even you don't need to write this expression also. You can directly jump to the next part. What is the next part? Suppose say I am going to find out the fundamental frequency. V01, one is the fundamental frequency, omega t. So what will be this expression? This expression will be 4 VDC n equals to 1, this by pi cosine of theta, directly cosine of theta into sine of omega t. This is the expression of the fundamental frequency of the fundamental waveform. So now if I find it, then we can find this is the value of maximum value. So if I write it V01p, that is the peak value of V01, what is that value will be? That value will be 4 VDC, that is the peak value of the fundamental waveform, the peak value of the fundamental frequency, by pi cosine of theta. Now if I find out what is that modulation index is expressed, modulation defined as the ratio of peak of the fundamental component. So peak of the fundamental component we have found out, this is the peak of the fundamental component. Okay, next peak of the fundamental component of VAB, this one, to the applied DC value. So applied DC value is the VDC. So now if I find out, that is that V01p by VDC, which is equals to 4 by pi cosine of theta. So this is nothing but equals to modulation index m, and what is the value of the modulation index has been given? This is 0.8 possibly. Let me check one second. Modulation index is 0.8. Now this value is 0.8, which is equals to 4 by pi cosine of theta. So we can write cosine of theta equals to your 0.8 pi by 4. So we can write 8 pi by 40. So we can, let's go to 5. So this is equals to pi by 5. So what is the theta value? Theta equals to cosine inverse of pi by 5. Okay. Now let me calculate this value, cosine inverse of pi by 5. So just a minute. cosine inverse of pi by 5 I will find out. Pi by 5. So I am getting 51 degree, 51.073. So in approximation I am considering 51 degree. So in degree it is asked. So in degree if it is asked, so let me go to this part. Sorry. So this is the answer should be 51 degree. Degree is in degree, expressed in degree, so it will be 51. 51.07 is a round of if it is asked, so 0.07. So 2 decimal places. So this is problem 1 is solved. Very easy. Once if you can directly remember this one, then you can remember this one, then this will be the calculations, it will be much easier. If not, you quickly find out this value, this one. Even if you are not able to find out this one, at least you find out this one. This is the peak value of the fundamental component. Means if you replace this n equals to 1, that will be the peak value of the fundamental component. You find out this one, then you will get it. From where I am going to get, I am getting this one from this expression, this waveform. Okay, so you have to observe this waveform, how it is, whether there is a symmetry, half wave symmetry or quarter wave symmetry exists or not. Based on that, you have to go for the calculations. Okay, now let me move ahead to the next problem. Problem number 2. In problem number 2, what is asked that a single phase inverter is fed from 100 volt DC source. So inverter is fed from 100 volt DC source. What is the type of the inverter? Single phase. Okay. So what is VDC? First I can write VDC equals to 100 volt. Fine. Is controlled from a quasi square wave modulation scheme to produce an output waveform VT. So this is VT actually. As shown with this one. This is the quasi square wave output. Now we have to find out the angle, this one. I think something other, this one angle is missed out, this one angle. We have to find out the angle is adjusted to entirely eliminate the third harmonics. So the angle is adjusted such that third harmonics is eliminated from the output voltage. Now under this condition, Vt, the magnitude of the fifth harmonic component as a percentage of the magnitude of the fundamental component is how much, that we have to find out. Okay, sorry. So here the waveform which is given here is the quasi square wave, and this one is similar to the previous one. So if I directly use this one, this expression I will directly use, not this one, this expression I will directly use. Derivation is quite similar we have to derive this one. I am going to directly use this expression, okay, because waveform is similar. So what is the output waveform will be, that will be the V omega t, which is equals to summation. This one is very important. You please be familiar with how to solve this one, this type of how to derive this type of expressions. I have extensively covered in my previous lectures how to derive this one. Still, if you are getting some issue, you just try to resolve that part. Okay, so what happens, this one will be 4 VDC is this one by n pi cosine of n, this one, the sine of n omega t. This is the expression. Now what is said, that this angle is adjusted in such a way that the third harmonics is completely eliminated. So therefore the magnitude of the third harmonics is 0. Now let us find out the third harmonic component. So magnitude of the third harmonics is, suppose the magnitude of the third harmonic is 0. That means, so what will happen, that let me change the color. 4 VDC by 3 pi into cosine of 3 this angle, this is equals to 0. This is the meaning of that this statement. Angle is adjusted, angle this one is adjusted to entirely eliminate the third harmonic component from the output waveform. So therefore, this, if the peak of this waveform is 0, that means this is completely eliminated. So for that, what will be this angle? That we have to find out. So therefore, we can say cosine of 3 sigma will be equals to 0. So we can write this one as a cosine of, suppose say in pi by 2 or pi by 2 I am writing here, smaller one I am taking, because this is pi by 2 if I take it. So the angle should be between 0 to pi by 2. So therefore this one will be pi by 6. Okay, so this will be the angle where the third harmonics will be eliminated. That is how we have to solve it. Now once the third harmonic is eliminated, we have to find out the ratio of the magnitude of the fifth harmonic component as the percentage of the magnitude of the fundamental harmonic component. So if I am able to write here, let's see, this one is the V5P by V1P. How to get this? 4 VDC by 5 pi into cosine of 5 into pi by 6. This one here also 4 VDC by 3 pi, which is equals to cosine of, sorry, I'm extremely sorry, only pi, and cosine of pi by 6. So this one will be how much? VDC, 4 VDC by pi will be cancelled out. So we will get 1 by 5 into cosine of 5 pi by 6, cosine of 5 pi by 6, and cosine of pi by 6. Now how much this is? This is how much is the value? Let me calculate. If I calculate this value will be 0.866 like that. So both will be same. So this will be 1 by 5 only. So this is what? 0.2. This will be 0.2. Now if I calculate this one is percentage, we will get this is equals to in percentage. If I find out, let me go to the next page. That is V5P by V1P. Oh, yes, correct. I have written correct. So you just calculate this one, you will get minus of 0.866. If we take the magnitude of this one, this will be 0.866 as a numerator, and denominator also 0.866. So this will cancel out. So this will be equals to 0.2 into 10 to the 100%. So this one will be percentage of this, percentage of this equals to this one is 20%. So this will be the answer. Let me go to this place and put the answer in as a percentage. So this will be, value will be 20. This is problem number 2 done. Fine. So this is how we will deal with the harmonic elimination part. So now next problem. This is problem number 3. What it is asked? Output voltage of single phase full bridge voltage source inverter is controlled by unipolar PWM. So what is unipolar PWM? I have discussed VDC and 0, between VDC to 0, VDC and 0, or 0 and minus VDC. So this is the unipolar PWM with 1 pulse per half cycle. So this one is 1 pulse per half cycle. So there will be only 1 pulse, single pulse modulation, SMP. So SPM. So this is single pulse modulation, one pulse per half cycle. The fundamental RMS component of the voltage is 75% of the DC voltage. Fundamental RMS component of the output voltage. So fundamental, we have to find out the fundamental component, peak value. Then from the peak value, we have to go to the RMS component. Once we find out the RMS component, that RMS component with respect to DC ring voltage 0.75 or 75%. The required pulse width in degree, round up to this, round up to 1 decimal is this, to 1 decimal. Okay, so let me find out first. If we do it this way, so 1 pulse per half cycle, 1 pulse per half cycle, and it is not, I am expecting that not square wave, because output voltage is 75%, so it will not be, it's a square wave. So what will be the pulse width? Okay, so this is VDC, this is minus VDC, this will be the output voltage waveform. Now this is the width of the pulse. Suppose say D is the width of the pulse. I have already derived this one in last class, that this will be the 4 VDC by pi into sine D by 2. That will be the expression. Still I am going to, if you want, I am going to derive this one once again. So this is the pi by 2. So this is D by 2, pi by 2 minus of D by 2 is this position. If I find out this is pi by 2 minus of D by 2. If I find out the theta. So what will be the Bn will be how much? 4 by pi integration of, this is pi by 2 minus D by 2, this is pi by 2 VDC into sine in omega t d omega t. So this is how we will find out. So now this is 4 VDC by in pi, this one will be minus of cosine of in omega t, this one will be pi by 2 minus d by 2 to pi by 2. So what will be the final expression? 4 VDC by in pi, this will be cosine of pi by 2 minus d by 2 minus of, so obviously n will be there, n will be there. So this is minus of cosine of n pi by 2. So for odd values of n, this one will go to 0, and what is left out, this will be the 4 VDC by n pi, and this one will be sine of nd by 2. This is the expression, we will get it. This is the Bn, and that will be the, that this value will be the peak value of the waveform, because next part is the sine of n omega t. So if I find out the V naught of omega t, so that will be summation of n equals to 135 to infinity 4 VDC by in pi sine of in d by 2 into sine of n omega t, this one. This is the final expression of the output voltage here. Now this part, if you say this part is the peak value, this is the peak value part, this is the peak value. So now if I take the peak value, and what is this, and we have to find out the RMS value. So RMS value, peak by root 2, peak by root 2 will be RMS value, and that is the 75% of the DC value, DC voltage. So the fundamental component, yes, fundamental component. So if I find out the V1, V output voltage 1 in RMS, which is equals to 4 VDC by root 2 into pi sine of D by 2. This is the expression. Now if I take the VDC here, then this will be V01 RMS by VDC, which is equals to 4 by root 2 into pi sine D by 2. This one is what? How much? This is 0.75. That is 75%. So, or this one is 0.75, 0.75. Maybe now next line 0.75, which is equals to 4 by root 2 pi sine D by 2. So from there what I can find out? Sine D by 2. This is 0.75 into root 2 into pi by 4. This one. So how much this will be? You have to find out. This one will be D by 2 will be sine inverse of 0.75 into root 2 into pi by 4. This one. Now what is the value? Let me calculate this one. So we are getting versus sine inverse of 0.833 around like that. So which will give us 56.4 degree, what I can see here, 56.4 degree. So what is the D value? So D value will be equals to 56.4 into 2. 56.4 into 2. So 112.8, 112, 112.8. So this is the value, 112 degree. So and this is 112.8 degree. So this is the problem number 3. So this is how we can find out the width. This width will be 112 degree out of this is the total 180 degree. So this part is that this side and this side both are equally divided. Next problem. So problem number 4. A 3-phase voltage source inverter is supplied from 600 volt DC. So this is supplied from 600 volt DC as shown in the figure below. For star connected load with 20 ohm per phase, star connected resistive load is 20 ohm per phase. The load power for 120 device conduction in kilowatt is how much? That is what you have to find out. So first point is that RL is given, VDC is given. So first point which is given is VDC is 600 volt. RL is given, that is our 20 ohm. So this is RL given, VDC given. Now what we can find out, how we can solve? We have to find out the power. So power, oh, this is also per phase. This is per phase given. So if we can find out the phase voltage, so we can find out, if we can find out the phase voltage, then basically phase voltage RMS. If we can find out the phase voltage RMS, then per phase power we can calculate V square by R, and then this will be 3 of VPH RMS, this one square by RL. This will be the expressions. We can directly put it here. Now only thing is that we have to find out the phase VPH for RMS value of the VPH. This one we can find out for this one. Now if I if I go ahead with this waveform, if I can remember, as far as I can remember, that is the phase voltage waveform was like our pole voltage waveform. So what was the pole voltage waveform? That is, suppose a 60, 120, similar way, 180, 240, 300, 360. So now what was the waveform? Suppose one phase I am drawing. It will start from VDC by 2, and there it will come to the VDC by 2 and 0, and it will go here. Then again for 120 degree it will go VDC by 2, 0, then here, then again VDC by 2, it will continue. So this is plus VDC by 2. This is minus VDC by 2. So this one was the waveform. So this is pi by 3. This is 2 pi by 3. This is pi this way. This is 3 pi, 3 pi by 3, 4 pi by 3. This one is 4 pi by 3, 5 pi by 3. This is 2 pi. This one. So this is the phase voltage waveform. Suppose say R phase. So Y and B phase are 120 degree shifted of this one. So this is suppose say R phase. Now from this we can find out the RMS value. Now what is that? The VPH phase voltage RMS, how we can find out? This is equals to root, then the mean. So I am taking up to this point 0 to pi, and then pi to pi this will be repeated. So 2 by twice pi, or 1 by twice pi I am taking. So I am taking 1 by pi here. Integration of, basically this will be the twice will be multiplied with this one, 0 to 2 pi, 1 by 2 pi twice multiplied. So 2 to cancel out. So this will be 0 to, this is how much? This is 2 pi by 3. We will get the VDC 2 pi by 3. Then the VDC by 2, the square of that, VDC by 2 square into d omega t. So this is omega t. This is the root. So what we get it? 1 by pi, 1 by pi, your VDC square by 4 into this part will be 2 pi by 3, this one. So once 2 pi by 3, let me change the color, it will be easier. Pi cancel out, 2, this will be 2. So what is the expression we are going to get it? So this will be VDC by root 6. This will be VDC by root 6, this one. V phase RMS. Now we can, RL is available, V phase RMS we have found out, then we can directly put it here. So what will be the P expressed, total P power? This will be 3 into V phase RMS is the VDC square by, suppose say, this is 6 into RL, this is 6 into what is RL is 20. And now next step, let me put it 3 into 600 square. So 600 into 600 by 2, 6 into 20, 3, 2, we cancel out, 2, 300, and then this will cancel, this is 30. So what I can get? I can get this one as a 9000 watt. So 9 kilowatt. 9 kilowatt is the answer. So in kilowatt it is asked. So this will be 9 kilowatt. Okay. So this is problem number 4. Let's move on to problem number 5. Now, what it is asked, in the converter circuit shown below, the switches are controlled such that the load voltage VOT is 400 Hz square wave. Okay, the RMS voltage, RMS value of the fundamental component of VOT is how much? So basically, if I see here, this is the V output T, with omega t, suppose say this is the V output t, this one. So what was this one? This is 400 hertz square f. This is how it will be. This is 400 hertz, this is pi, this is 2 pi, and this voltage is how much? 220 volt, 220 volt DC minus 220. So this is the waveform. So how to find out the RMS value? Simple, the way I have explained earlier. So VO RMS, the fundamental okay, there is it is asked fundamental component, that will give the total component. The same way we will not get it. So we have to find out the VO1 expression. VO1 expression for 4 square F. I am just directly writing 4 VDC by n pi. N pi means n equals to 1 into pi into, this is the for square F, this is sine of n omega t, or omega t, this one. This is the fundamental one, fundamental voltage waveform. So now what is the peak value? Peak value is this one. Peak value is this one. So what is the RMS value? V01 RMS, which is equals to, this is 4 VDC by root 2 into pi. This is the RMS value in volts. So how much? Let me find out what is the value. This is 4 into 220 by root 2 into pi. So if I calculate this one, so we will get the value. Let me calculate. And so this is 4 into 220 divided by root 2 into pi. So 198.096, 0069. So 190 anything about the decimal? 198.07 volt. So this is very simple one. Only thing is that you have to know about this one. This one directly I have written fundamental. I have not written the summation part. That part I have not written because that is not needed here. You can write, then from there you can derive this one. Same procedure. The procedure has been explained many times, so I am skipping it here. So this is the solution of this problem. So I think any problem is left out? No. So that's all for this class, and that's all for the power electronics side. So thank you for following these lectures, and best of luck for your exam.